So in this model, we're ultimately interested in estimates for alpha, which are the means for the intercept and slope, and psi, which would include the variances and then the covariance for the intercept and slope. And that's basically the core of the model. Here are the three parameters in the model. Alpha is the growth factor means. Little theta, these are the error variances that are associated with the repeated measures data. And then this big bold psi, that's the matrix, which has the latent factor variances and covariance in it for the intercept and slope. So we have three types of parameters, and the model priors are also pretty basic for this model. The means will get normal priors with a mean and variance hyperparameter dictating what that prior looks like. These variances will receive inverse gamma priors, and then the covariance matrix gets an inverse Wishart prior. So now let's take a look at how to do all of this in Mplus. So here's the first part of the input. This explains that the data we're working with are from the early childhood longitudinal study. And this is where kids were tracked, as I mentioned, from kindergarten onward on many different variables. And the particular variable I extracted here was reading ability through just kindergarten and first grade. So I extracted 600 random cases from this database for us to take a look at. Then we can tell Mplus exactly what we want it to do. So in this data file, we have just 4 columns of data. Each column represents a different time point. So reading score will be for time point 1 is in there, and then time 3 all the way to time 4. Each row in the data file is a person. Then we can specify the different Bayesian elements that we might want for estimation, including the number of iterations. This one is huge, so if you play with this, you should cut it down smaller so it won't take so much time to wait for. But we would go through and specify if we wanted to override any of our default settings or not. Next is the model. So here is what the model means. The first line isMplus's code for telling it this is a latent growth curve model. And this is exactly how it would be specified. The I and the S indicate that this is a model with an intercept and a slope. If you wanted this model to, for example, have a quadratic term, you could type I, S, Q, and you would now have 3 latent factors. The third factor would be controlling the curvature of the trajectory that was estimated. So then we see this given sign, and this is basically Mplus's notation to denote that this is a latent growth curve model. Next, we list all of our repeated measures data. So this is the variable names that we gave it up here, mapped directly here, Y1 all the way to Y4. We have these @ signs because we're going to fix the loading values. And these numbers mimic the slope loadings that we saw up here. 0, 5, 9, and 15 are just mapped down directly into the code to denote that the first time point should be the y-intercept and that spacing was unequal. If I had had equal spacing, I could simply write 0, 1, 2, and 3, and that would tell Mplus that there was equal spacing in between the time points. Next, we set up the actual model. Anything in brackets is a mean or a threshold or an intercept. And so here, this is a mean for the latent intercept and latent slope. I gave starting values here. You don't need to, you can leave them blank, but having the asterisk right here, these stars will indicate that they should be freely estimated. And I simply just wanted to show you how to change the starting value to something that was your own. So these are the means. Next, we have the variances for the intercept and slope. And then finally, we request the covariance. We know it's a covariance because we use that with statement. In the input, we can save out the MCMC file that we'd like to use later, as well as any plots or various elements of the output we are interested in. Then the output starts. It will start by restating our variables and the roles that they are playing in the model. Again, we have 4 continuous observed dependent variables. These are the outcomes. And we have 2 continuous latent factors, the intercept and the slope. Next, we can see details of the Bayesian estimator that we set up in the code. And then we can start to see results. The first part of the results represents the fixed loadings. So this is really uninteresting. These are your fixed parameters in the model. The bottom 3 lines are the only 3 that really show us anything interesting. So we can see here the covariance between the intercept and the slope. It's in a non-standardized metric, and so it may be more interesting to convert this to a correlation, to talk about the correlation between the 2. And then we see the means. And so these become very interesting to us. This says that when little kids started kindergarten in the fall, their average reading ability was 22.8. And if I was an expert in reading, that would mean something to me. And over time, their growth rate was about 2.1. So they increased in their reading ability at that rate. And me as a substantive researcher in reading would know what that meant and be able to put a lot of meaning to that. Next, we see our intercepts, which were fixed in this model. And then we see latent factor variances follow. And this is how much variability that there would be in the intercept and slope across all the kids that you have data for. This could also be of great interest to us substantively. Notice that the variance for the intercept is huge. This shows a lot of variability. And this is something that we'll kind of tap into in a later lesson. Then we have residual variances for the repeated measures data. So if we wanted, we could look at standardized results, and this could be particularly useful if I wanted to look at that covariance between the intercept and slope on a standardized metric. That could be helpful for me to see. And then I can look at the Tech 1, which again isMplus's internal numbering system. So I can track which parameters have a particular number in case there was a problem with convergence. Next, I have starting values that Mplus uses. And this would also show you if you overrode, which we did, a couple of the starting values, they would pop up here. Here are the priors. These are the default priors. We have inverse gamma priors for any variances. We have our normal priors for the intercept and slope means, and then inverse Wishart for the latent factor covariance matrix here. I've not talked about Tech 4 yet, but this pulls out estimates in a quick to see format. I like asking for this, especially for models like this, the latent growth model, the latent growth mixture model that we'll talk about later. I think it's just a quick and easy way to see the estimates that are pulled. And this would be, again, the median of the posterior distributions that are produced. Tech 8 will show us which parameter had the biggest convergence problem at every 100 iterations of the chain. This is really helpful because it can help us to solve any convergence problems that pop up. We would know which parameter was having the most difficulty. We could go to Tech 1 and see what that parameter was, and then maybe think about if we need to change something about it, maybe even the prior, or just extend the length of the chain. Then the output always tells you what plots are available that you've asked for. And finally, we get information about the MCMC file that we requested to be saved and the order of information that was contained with it. And this is what we can read into R if we want.